It's useful to look at units when you're doing physics. It helps scientists to know if they've made a mistake in calculations, for one. If your units don't turn out right at the end of your calculation, something is wrong. We can look at the universal law of gravity in terms of the units involved and see that it makes sense. When using dimensional analysis and problem solving, you're simply keeping track of the units in your quantities. So here is our universal law of gravitation. The gravitational constant times the mass of one object times the mass of the other, divided by the radius or the distance between them squared. The first thing we need to do is look at the units for the gravitational constant. We can put those in place of big G. So the gravitational constant is newtons times meter squared over kilogram squared. Then the mass of one object is kilograms times the other object's mass, kilograms, all over meters squared. What we do next is we need to cancel out units that we see on the top and the bottom. It's just like having a big fraction. So here we cancel out m squared, meter squared, with m squared on the bottom, meter squared. And we cancel out kilograms times kilograms with the kilogram squared on the bottom of the fraction. Well, that leaves us with a gravitational force in newtons, which is what we want to see, because we know force is indeed measured by newtons.